So to do exactly, this example comes out of section 11.2, combinations. So in this example, we're told that a class has 16 girls and 14 boys, and the principal wants to select a grad committee from that class of 5 students. How many selections are possible? We're not given any kind of restrictions or told that there's any particular roles or designations on this grad committee, so all we're left with is it's going to be 30 people altogether, and we're going to choose 5 of them. The reason why it would be choose and not permutations is that, again, the order of this selection doesn't matter. If I choose 5 people to be on the committee, it's the same 5 people, whether I choose them 1, 2, 3, 4, 5, or 5, 4, 3, 2, 1, and there appears to be no difference between what their jobs are. So, big number, 142,506 different committees possible. So part B says how many selections for these committees would have exactly 3 girls and 2 boys on them. So now we've got some more specifications. We have to select our girls, meaning we have to say 16, choose 3. Again, order not important, but they do need to be girls. And then we also need to choose 14, choose 2 for the boys. We multiply these numbers together because we're choosing 3 girls for the 3 girl positions and 2 boys for 2 boy positions, but it's both of those things, and so we multiply those 2 numbers together to get a big number again. And as much as this number specifically doesn't mean that much to you, the fact that we have 50,960 committees that would have 3 girls and 2 boys, it does make sense that it's a much smaller number than when we had no restrictions at all, that we could have had 5 girls, 5 boys, 1 girl, 2 girls, 3 girls, 4, etc. Any possible mix of girls and boys. There are 142,000. So the last part of this one says, how many selections with 3 girls and 2 boys are possible if one of these girls must be Claire? So, for whatever reason, Claire needs to be on the committee. Maybe she's the principal's daughter, maybe she's the valedictorian, whatever the reason may be. There's only one way to select Claire. You can write 1, choose 1, but really, there's one way of getting her on the committee. Now we have 15 other girls, and we only need to choose 2 of them, because now we'd have a total of 3 girls on the committee, and we still remain with our 14, choose 2, and so we multiply these numbers together, and again we have a smaller number than we had a second ago. So we have 1 times 105 times 91 this time, and it's 9,555 committees. Still plenty, but again you'll notice more restriction means fewer combinations, fewer possibilities. And again, hopefully pay attention to why we're using C and not P, why we're using combinations, because the order of selecting these people doesn't matter. Second example here says the test has 2 parts, and there's 5 questions, you have to pick 2 of them, and then there's 6 questions in part B, and you have to pick 3 of those. So it's in terms of marking this test, I wouldn't care whether you picked the first 2 questions or the next 2 questions or whatever. The order of these wouldn't matter. They're probably worth the same amount of marks. So we're going to have 5 choose 2 for the first section times 6 choose 3 for the second section. So that part seems fairly straightforward. Still quite a few different answer keys for me to make up for this. We have 10 ways of selecting the questions for part A, 20 ways of selecting questions for part B. 10 times 20 gives us 200 different tests we could have. Now, if we just alter that slightly and say, what if we could choose at least 4 of the part B questions? So let me write that. So some kind of unusual test here where you get to pick 2 of the first section and then at least 4 of the next section. So must be some kind of interesting sliding scale for grades on this one. But if you decide to do exactly 4 questions out of that second section, you're going to have 5 choose 2 times 6 choose 4. But you could also do 5 questions, so exactly 5. It will be 5 choose 2 from the first section, 6 choose 5. Choose 5 from the second section. Or finally, the other possibility is to do exactly 6 of the second set. So you got 5 choose 2 times 6 choose 6. Those are all separate possibilities, separate ways of completing this test, and so they're going to give us a different answer each one. So to do exactly 4 questions, it leaves us with 150 ways of completing that test. To do exactly 5 questions leaves us with 60 ways of completing that test. And to do exactly 6 means you do all of the second set, and you still have the 10 different ways of selecting the first. So 10. The word or, as we've said a few times before, means add these possibilities together, and you end up with 220 different ways of completing that test that would have at least 4 questions picked from the second set. Those words like at least, at most, more than, less than are definitely words you want to underline, highlight, circle, do something when you run into those in a question.